Hello everyone, topic is oxidation of 1 degree and 2 degree alcohol by Collin's reagent. This is the last reagent that we are dealing for the oxidation of alcohol. Its mechanism we will discuss in this video. The topic is not included in the syllabus of 12th class. It is for JEE Advanced and B.Sc. Collin's reagent. Let's check what it is. Chemical name. Dipyridine chromium trioxide in CH2Cl2 as a solvent. This dipyridine chromium trioxide in what solvent? CH2Cl2. Means this chemical we are going to dissolve in this solvent dichloromethane, so we will get Collin's reagent. On changing the solvent, like suppose the same chemical we are dissolving in pyridine, then the name of the reagent will change to Sarret reagent. So between Collins and Sarret, there is a difference of solvent only. In Sarret, pyridine is working as a solvent, and in Collins, dichloromethane is working as a solvent. This is the formula CrO3.C2H5 C5H5N, formula of dipyridine chromium trioxide complex. So let's first understand how Collin's reagents are prepared. Mechanism wise, Sarret and Collin both are same. Only the difference is of solvent. So how Collin's reagent is prepared? Let's check. This is chromium trioxide, orange color compound. In this we are going to add colorless liquid pyridine with a colorless solvent dichloromethane DCM. In this condition, now first let me tell you about chromium here, because chromium is connected with oxygen with 6 electrons it is sharing. So as you know, oxygen is more electronegative than chromium, so all the 6 electrons are going toward oxygen side. That's why it is carrying partial +6 charge, due to which partial vacant orbitals are generated around chromium, d orbitals. In those d orbitals, this nitrogen of pyridine with a lone pair will start filling its electron partially. Means around chromium, such type of bonding will be developed from pyridine side. Partial vacant orbital on chromium, due to which lone pair of nitrogens are going on in those partial vacant orbitals. Means a dative type of bond will generate between pyridine molecules and this chromium trioxide. Two pyridine molecules will make a dative bond type bonding with chromium. This complex is known as chromium dipyridine chromium trioxide complex. Chromium trioxide, which will get dissolved in DCM, dichloromethane. The color of this compound will be red color. Now let's check how it will perform its oxidizing action. And Please check CrO3 plus 2 times pyridine molecules will be required there. That was not written, so please check. 2 pyridine molecules will combine with that CrO3. One particle of CrO3 will be coordinated by 2 pyridine molecules. Now how it will perform its action? Number one, first we should know directly. It will oxidize 1 degree alcohol to aldehydic stage, 2 degree alcohol to ketonic stage, and 3 degree alcohol will not react with Collin's reagent. Let's understand why. To get the answer and the full explanation, firstly we need to understand the role of temperature while making Collin's reagent. As you know, Collin reagent is prepared by adding chromium trioxide with pyridine. It's a exothermic reaction, highly exothermic reaction. During this process, when you are mixing chromium trioxide with pyridine, lot of heat energy is generated. That lot of heat energy can decompose this chromium trioxide. So it is mandatory to maintain the temperature. That's why the reaction we will carry out in ice bath, due to which temperature of the reaction will be maintained from 0 to 5 degrees Celsius. So Collin reagent will be prepared under very low temperature. Very high temperatures, because heat energy is already getting evolved during this process. So to control the reaction and protecting this chromium trioxide from decomposition, we are performing this reaction in ice bath, which will maintain the temperature 0 to 5 degrees Celsius. So this temperature role, please note down. Now let's go for the mechanism. With 1 degree I am going to start. The general formula of 1 degree alcohol is this. Same mechanism already we have done. Not so many changes. Only the point is this chromium trioxide is partially coordinated by pyridine molecules. This chromium is in +6 oxidation state due to loss of 6 electrons. Now it have a tendency to attract electrons because it's a highly positive particle working as electrophile. Who can provide electrons? This oxygen of the alcohol. Lone pair is ready. It will completely transfer its lone pair to the chromium, not like pyridine, not partially, completely, due to which the previous pi bond, total 6 bonds are there, one pi bond will break because maximum chromium can make 6 bonds. So obviously the 6th bond will break and electrons will shift toward oxygen. This oxygen already carrying 2 lone pairs, so please draw them. After this shiftage, what we will get? Check. This mechanism, this type of mechanism we have discussed many a time in previous videos. This oxygen is going to make coordinate bond with chromium, and this oxygen will get extra lone pair, this lone pair, due to which it will carry -1 charge, because in this lone pair 1 electron is of chromium which this oxygen is getting. That's why -1 charge extra. Rest part as it is, these pyridines will be there like this. After this we know what will happen. This oxygen is unstable. Why it is carrying a +1 charge? Because out of 2 electrons, 1 electron it will completely shift toward chromium for the bond formation. 1 it will keep it with itself because it is losing its 1 electron. That's why it is carrying +1 charge. In this condition the oxygen is unstable. What it will do? It will break bond from its hydrogen and will shift electron toward itself, due to which H positive particle with a vacant orbital will generate. It's a electrophile, wants electron. Who can provide electrons easily? This oxygen, because this oxygen is carrying extra lone pair which is making it unstable. -1 charge is there. That's why it is unstable, it is unstable. They both can help each other. That's why they will make a bond, due to which a new compound will generate that I am going to write here. this oxygen will become stable because it is getting one extra electron of the hydrogen, so the +1 charge will finish. Here this oxygen will make second bond with hydrogen, due to which you can check negative charge of this oxygen and positive charge of this hydrogen will become neutral. Because one extra electron that this oxygen have, it has transferred it toward hydrogen, due to which its minus charge is finished, due to which hydrogen was having a shortage of electron, it is getting that one electron, so its positive charge will finish. Rest part as it is, no change. Still you will find chromium is in +6 oxidation state. This one. What is this? This is chromate ester intermediate. Chromate ester. In previous videos, many a time we have used it. Now in this chromate ester, what is the special about this chromate ester? This chromate ester is made up of oxygens, and we know oxygens are highly electronegative. So this whole part is strongly attracting electrons from the carbon side. This one. These electrons are strongly pulled toward this group, due to which this carbon is attracting electrons from its hydrogen. That's why these hydrogens are carrying very high positive charge, due to which they are working as a acidic hydrogen. Means they can be released out from here very easily in the form of H positive. But who can release out them? There are two ways by which they can be released out. The first way is with the help of a base. Which base? Unreacted pyridine particles are working as a base here. Some unreacted pyridine particles will be there. This one. You can check. This nitrogen is carrying a lone pair, and this lone pair have a tendency to accept H positive with a vacant orbital. Vacant orbital, lone pair. In this fashion they can be coordinated, due to which pyridinium ions will generate. Because this nitrogen will transfer one electron completely toward hydrogen for the bond formation, dative bond it is. That's why it will carry +1 charge, and such type of particles are known as pyridinium ion. So this is the first way in which this H positive can be released out. Second way, this H positive can be accepted by this oxygen also. How it will receive this H positive? Obviously it will break bond from chromium like this, and these pi electrons it will transfer toward hydrogen for the bond formation. So OH will generate there. So these are the two ways by which these acidic hydrogens will be released out. Now what about the carbon? Because carbon will get electrons from hydrogen, these electrons it will transfer toward oxygen, because this whole group is electron attracting group. Now we know oxygen is stable with two bonds, so third bond it is making, so obviously this bond will break, this chromium and oxygen bond. How? These electrons will be pushed toward chromium. Reason? Because from here electrons are coming, they will repel these electrons. So please focus on this part. What will this part will become? It will become R CH, and here double bond will generate O, aldehyde. In this fashion this compound will be converted to, this chromate ester will be converted to aldehyde. What about this part? If H is attacking here, so next condition will be this, and electron will be shifted from here to chromium. Here chromium will have +5 oxidation state. You can check. Right now it have +6. So when it will lose electron completely toward oxygen, still +6. At that time one more electron from oxygen side it is coming toward chromium, so +5. Means from +6 to +5 oxidation state will change of chromium during this process. Aldehyde is generated. Now can aldehyde be further oxidized by this reagent? We know in previous videos we got that information. For aldehydic oxidation, firstly it need to react with water to create hydrate aldehydes. This H positive will attack on O, this OH will attack on carbon, bond will shift, and this compound must be created. We call it hydrated aldehydes. But for that you can check water molecules are required, and in this Collin reagent water molecules are not available. That's why aldehydic oxidation will not happen further. That's why Collin reagent is able to stop oxidation of 1 degree alcohol up to aldehydic stage. Now next, 2 degree alcohol. Same mechanism for 2 degree alcohol. This is 2 degree alcohol. Directly I am going to write the step up to chromate ester. This one. So here again, this is directly I have written. Please try the whole mechanism by yourself. You will get this chromate ester. Chromate ester. Up to here same like 1 degree alcohol. Only the change will be here. Now this chromate ester is strong electron attracting group. Electrons will go toward oxygen side, due to which in turn this carbon will start attracting electron from its hydrogen. So this hydrogen will become highly acidic, due to which the bond will break and electrons will be transferred toward oxygen, and these electrons will further shift it toward chromium. Same mechanism. And what we will get? Between this carbon and this oxygen, double bond will generate. What is this? This is ketone. And this H positive which will release out can be stabilized by pyridine, as I told you, or can be stabilized by these oxygens. So suppose I am stabilizing this H positive by oxygen, so the released product will be this. And in 1 degree alcohol case, please check when I released this chromium, I have not made p-wise pyridines there. So please add pyridines there. They will remain in the contact of chromium. Don't forget them. One lone pair will generate extra on chromium because from this side electrons are coming. Still the oxidation state of chromium will be +5. Please check and count oxidation state. It will be +5. So ketone will be generated. Now can ketone oxidize further? For ketonic oxidation, we need to convert ketone into enol first. As we know how oxidation of ketone is being done. First it will convert itself to enol, and enols will further oxidize. But for the conversion of ketone to enol, acidic conditions are required. But in pyridine, this dipyridine chromium trioxide complex, we don't have acidic medium. We are using that solvent which is dichloromethane, not acidic, and rest reagents are not acidic in nature. So that's why ketone cannot be converted to enol. So if ketone is not converting itself to enol, how it can further oxidize? That's why 2 degree alcohols will stop its oxidation up to ketonic stage in the presence of Collin's reagent. Now whereas 3 degree alcohol, we very well known to 3 degree alcohol. 3 degree alcohol first show the process of dehydration. It will create alkene firstly. But for dehydration, what conditions are required? Acidic conditions plus temperature, high temperature. Both conditions are not available in Collin's reagent. Number 1, it is not acidic. No acids I have used. Sulfuric acid, hydrochloric acid. Acidic conditions are not there. Temperature, if you talk about temperature, so the starting temperature condition I told you 0 to 5 degrees Celsius. And finally, if you are using Collin reagent mixture, the temperature will be maximum 25 degrees Celsius, means up to room temperature it will work. But for dehydration of 3 degree alcohol to alkene, at least 443 Kelvin temperature we require, which is not available. We are not heating that. So that's why 3 degree alcohol will not dehydrate further to alkene, and if alkene will not generate, further oxidation of alkene cannot be done. That's it. This is the end of the Collin's reagent and its mechanism. 2 degree, 3 degree alcohol, this dehydration, alkene, enols, you can check from the previous videos. Every information is there. Please check it. That's it. This is the end of the video. Now, in next video, we will discuss reaction of alcohol with copper, with its mechanism. Thank you very much.